All right, so student asked for some extra practice with simplifying square roots, and I just want to make sure we know this is actually a skill we would have learned in a previous class. So college algebra, we assume that you already know how to do this from intermediate algebra or even classes before that, but I do want to help make sure that you have some exposure to a review of it since you asked. And so I found a site. I just Googled extra practice, simplifying square roots, and Khan Academy is awesome. Sorry. And I found this great, I'll share the link with you. If you are interested, just message me in Canvas inbox, but I think you'll be able to find it pretty easily if you just search it up the way I did. Simplifying square roots is what I put into simplifying square roots practice, and then I found the Khan Academy link right there. Okay, so this is going to let us do some, give us some different examples to work on, and I brought that one over here so we can start with that. And this might be more advanced than a lot of the ones that you're seeing in your assignment, but depending on which part of the course we're in, we can see ones, examples that can get this complex or even more complex. So this will be, good practice in general. All right, so now what I see here is that we're multiplying two expressions that each have a square root in them. And when you are multiplying, you can kind of simplify by moving the terms around. It's called the commutative property of multiplication, meaning that each of the factors, we call these factors because they're multiplying. So 3 is a factor, the square root of 5a is a factor, 8 is a factor, the square root of 35a squared is a factor. So we can move some things around for our convenience. So I'm going to put the 3 and the 8 next to each other. And then I'm going to put the square roots all together under one square root. And this is something we can do. This is one of the properties of square roots. I'm also going to rewrite the 35 as 5 times 7. And I'm going to write the, I'll just write a squared. Now anything that's squared under a square root can simplify out. So just like if we had the square root of 9, we could simplify that to 3. Or even if it was written as the square root of 3 squared, we could write that as 3. Or if we had it written out as the square root of 3 times 3, since the index here, which we don't see on a square root, but this is the invisible index is 2. So anytime you see a pair, 2 of the same factor underneath that square root or second root, you can have one of them come out. It's like one of them comes out only. So these all simplify to 3, right? Also, it technically could be -3 times -3 to give you 9, right? So we always have to consider the positives and negatives, but generally when you're just working with, numbers like this, we're not solving here. I guess I'll say that. We're not solving. The general rule is to just assume they mean positive. But when we're solving something like later, we might have something like x squared equals 9, and we're going to need to solve for x. And in that case, you would take the square root of both sides. And when you do that, you have to always put a plus minus on the side opposite the variable because it could be plus or minus 3. That would make your equation true. So you have to consider the possibility. But we're not solving here, and just when you're simplifying radicals, more often than not, you're just expected to assume we mean the positive root. So just as a side note, that used to confuse me when I was a student. Okay, so this right here, 3 times 8 simplifies to 24. So I'm going to go ahead and simplify that. I see a pair right here. So that's 5 squared or 25, and the square root of 25 is 5. So that can come out from underneath the radical sign. Also, I see that I have a squared, so a can come out. Okay, so those have been simplified, and then I just have the 7 remaining underneath the square root because 7 is prime. It can't be broken down any further, and it is not a perfect square. And then we would just simplify by multiplying 5 times 24. Now, as a side note, you can do that in your calculator, obviously, but it's interesting. 24 times 5 is the same thing as 5 times 24, and 24 can be written as 20 plus 4. Sorry, something happened with my pen here. Let me just fix this. Okay, I think we're good. So I wanted to point out that, we learned the distributive property of multiplication, and we can do it with just regular numbers. 5 times 20 is 100, and 5 times 4 is 20. So 5 times 24 is 120, right? So I'm going to rewrite that as 120 square roots of 7. And it honestly doesn't matter the order that you write them in. You might write it like this, putting the variable at the end. You just want to make sure that your radical sign only extends as far as, to contain what should be underneath it. Just be careful you don't extend it too far. So I typically leave my variables out in front of the radical just to avoid confusion about what's underneath the radical sign. But really, there's lots of different ways you could write that would be considered correct. Now we can go ahead and put this in. 120 square roots of 7a, 120 square roots. Where's my square root? There we go. What was it? 7, square root of 7 underneath the radical. And then outside the radical, a. So let's check it. Not quite yet. Give it another try. Did I forget something? Oh, I forgot one of the A's. Yeah, there's 3 A's total. Let me put another A in there under the 7, or I mean with the 7 under the radical. Woohoo! I got it. Okay. So I guess I didn't, yeah, I just completely neglected that extra A there. And so there's actually 3 A's underneath the radical sign, but only one of them, or I'm sorry, only the squared pair can simplify out. So this A here that I forgot to write down, oh, sorry, this A that I forgot to write down was still supposed to be underneath the radical, like, right there with this 7. Yep. Okay, good. Should we do more practice? Let's see if we can regenerate this. Let's see, next question. Oh, okay, so it's just giving us another one. So let me snip that so we can work on it. Sorry, things are starting to move kind of slowly on my computer. I might pause it next time. Okay, so here, multiply and remove all perfect squares from inside the square root. So we're doing the same thing again. So I'm going to rearrange some things. All of these are square roots, so all of them can be combined into one big square root. So I'm going to just kind of strategically write down all the things into underneath this one single square root, all the radicands. So, but I'm going to take the 30 and actually, you know what? I think I'll write the 30 and I'll factor it. I'm going to factor that 30. Okay, so I'm going to write, instead of 30, I'm going to write 6. Something's happening with my pen, sorry about that. 6 times 5 for that 30 right there, okay? Then I guess I'll grab another color. So I'm going to just cross that 30 off because I already took care of that. Then I'm going to bring another color here just to help me kind of color code these things. Then I've got my 35 there. So I'm going to write that as 5 times 7. And I don't know why I'm seeing some weird stuff popping up. Please try to ignore the weird extra things popping up. Yeah, that should not be happening. Ugh. 3 times 5 and then 5 times 7 is what I want next. Did I take care? Okay, good. It's not doing it anymore. Oh, there it is. Oh. Okay, cool. So I got my 35 written out in factored form. And then I'm going to put my z's next to each other. So I'll do this z. I've got one there. I've got two z's here and three z's over here. So altogether, I have 6 z's. Z to the power of 6. Now, if you want, you can write them out if it helps you. And I think it might help you to see it so that the 6's are all written out. But I want you to notice that there's something, before I go on to rewriting another step, I've got these 2 5's right here that I'm going to go ahead and simplify out. So that is going to simplify to a single 5 outside of the radical. Okay, then I've got my radical sign, and then the 6 times 7 is going to be 42. Okay, there's no perfect squares that divide evenly into 6 or into 7. So that's why I went ahead and just did 6 times 7 and simplified it to 42, because that's going to have to stay underneath. And then the z's, I'm just going to write them out. Z times z times z times z. That's 4 of them. 5, 6. Okay. So why would I expand that? Because I want you to be able to see. Remember, the index of this radical is 2. So any pair of 2 factors can simplify out of the radical. Right? So now I have 3 pairs of z's that can simplify out of the radical. So I can have one z come out of the radical for each one of those pairs. So that would be 3 z's, or z to the 3rd power. And then the square root of 42 will just stay as it is. Okay, so 5z cubed square root of 42 by 5z to the power of 3. Then I'm going to use my arrow key to get down to ground level, and I'm going to put the square root and then put 42. And let's check it. Woo! Man, I like that. That's fun. Okay, maybe we could do one more. And I will pause the recording while I set it up, just to save us a little time. All right, so here we have a new example. I'm going to rewrite this problem down here. I already see that the z squared is going to simplify, so I'm going to put that z out here, okay? It looks like the way I wrote it, I'm kind of not liking the way that looks. Let me just write it a little better so it doesn't look like the z is in the position of the index of the radical. There we go. Z times the square root of. Now y is to the power of 1, so y is going to stay under there. I know that. But 75, maybe there's a hidden perfect square in there. And you know, it can help to know your perfect squares by heart. So if you just do like a list of them and, you know, kind of get used to what they are, you might already know a bunch of them, but, you know, see how many you can memorize, because it's definitely helpful for simplifying, and it can be nicer than having to constantly go to your calculator. It can be kind of tough to simplify these without having these memorized. So I love the idea of just, you know, maybe making a list of them, quizzing yourself. So I'm just writing them out. I would go at least up to 12. At least those are the ones I know by heart. Actually, I think I know up to 13 squared. I think that's the last one I have memorized. Okay, so notice that 25 is a perfect square, and I know that 75 can be rewritten as 3 times 25, or 25 times 3, and the square root of 25 would be 5. So now I'm going to write 5z times the square root of 3y. 5z times the square root of 3y. 5z square root of 3y. Is that what it was? Woohoo! Okay, let's do one more. I'll go ahead and pause it again. Here we go. This one looks pretty fun, right? It's definitely going to be fun because it's got a lot of stuff going on there. So let's begin by taking the things that are already outside of the radicals and combining those. 5 times 4 is 20. So that's just going to simplify everything for us. Then let's make one square root for everything because they're both of these factors, these radical factors are index of 2 or square roots. So we can put them together. And then I'm going to break down the number parts into their factors. So 14 can be broken down as 2 times 7. And 21 factors to 7 times 3. And then I have 5 z's. I mean, this z squared, really, why don't we go ahead and bring that out? Because we know anything that's squared simplifies. So we'll just put that z out there. And then we've got 3 more z's over here. Well, 2 of those z's can be simplified out, right? So we'll do that in the next step. And we also see that the 7's can simplify out. So we have 7 squared or 49, which is a perfect square, and then z squared, and those are both going to simplify out. So now we have the 20z that was already there, okay, and then my radical. And I'm going to put the 7 out there. So this is going to come outside the radical as just a regular 7. And this pair of z's is going to come out as just a single z. And then what is left underneath the radical is 2 times 3, which is 6. Okay, 2 times 3 is 6. And then I've got that last lonely z, okay? And we can simplify what's on the outside of the radical, so it's a lot nicer looking. So we have 20 times 7, so that would be 140. And then z times z is z squared. So this should be our final answer because we've simplified everything we can. Right? 140z squared times 6z. 140z squared times square root, oops, square root of 6z. Woohoo! Okay, keep going. You've earned a bonus question. Oh my gosh. Well, then we have to do it, right? What's the bonus question? Oh, fun. Okay, we've got 2 variables this time, but I'm not scared of that. Let's go ahead and copy it. I don't think I need to pause it. I feel like I can do this pretty quickly this time. My computer's behaving better than it was. Just so happens I had 3 slides ready to go, or I mean, how many? 5 slides ready to go on my last slide that I had prepped. So it must be meant to be. Okay, so we have, I'm just going to expand what I can underneath there. So 8 I know is 2 times 4, and I also know that 4 is 2 times 2. So 8 expands to 2 times 2 times 2. And then the x cubed, x times x times x. And I'm going to extend my radical a little ways here. And then of course the y squared would just, actually, yeah, why didn't we just take that y squared out? That part was easy enough for us to just put it on the outside. So let's take that y squared term and put it on the outside of the radical so we don't have to think about that part anymore. So now we're just going to simplify what's still underneath the radical, see what else can come out. Okay, so y is out there. What else can come out? Well, I see a pair of 2's here. So 2 squared, or 4, the square root of 4 is 2, right? So we'll put that out here. And then we have x. We have a pair of x's here. So that will come out as a single x, right? So those are taken care of. Then what is left over is just this 2 right here. and this little x here, okay? And I think that's all simplified already. So 2xy times the square root of 2x, okay? 2xy 2xy times the square root of 2x. Woo! Boy, that feels good. All right, so I am going to go ahead and stop here. Maybe you will decide that you want to come to this website and, there's other stuff here. It looks like there's some lessons, like videos and, more good stuff there. So that could definitely be helpful for you, and I hope it is.